So for every class, there is a live recording which I have been uploading in the YouTube, all right, and I am providing you the link in the study material option of the app, so you can, for revision purposes, you can always look on that, all right? Yeah. So question number 15 from exercise 9.1. Question number 15. We are going to start out with this question number 15 in today's class. So let's see the question. Okay, as I read the question, I want you to refer to your textbook so that we will have clear idea on what is given and what are the things that are required. Okay. So question says, a straight highway leads to the foot of a tower. So there is a highway which is leading to the foot of your tower. Okay. And a highway has been connected to the foot of the tower. A man standing at the top of the tower observes a car at an angle of depression 30 degrees, which is approaching the foot of the tower. Oh, it means the car is coming towards the foot of the tower. All right? With a uniform speed, without changing the speed. Uniform means something which always remains constant, something which does not change with time. All right? Yes. Suppose the position of this board is kept constant, right? Starting from the first day of the class till today, till the fifth. Today is the fifth class or sixth class. Till today, this board has not been moved from its position. So this board has kept constant. That is the meaning of uniform, keeping something unchanged. All right. So the car is coming towards the foot of the tower with a uniform speed, means without changing the speed. Okay. So when the observer first looked down at the car, the angle of depression was 30 degrees. 6 seconds later, the angle of depression is found to be 30 degrees. See, 6 seconds later, since the car is coming towards the tower, after 6 seconds, the car will be more closer to the tower, right? At that time, when the observer looked down, the angle of depression is found to be 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. So, okay, let's see. Let us draw the figure and accordingly we will sort it out, okay? I think, all right. So there is a straight highway which leads to the foot of the tower. So this is your tower. Let's say that AB is your tower. A is the top of the tower, B is the foot of the tower. There is a straight highway which leads to the foot of the tower. So let me draw the highway. So this is the highway. So a straight highway leads to the foot of the tower. Now the observer is at the top of the tower. So the observer is at the point A. Okay? From the eye of the observer, you always need to draw a straight line, horizontal line. All right? The observer is at the top of the tower. So from the observer eye, you always need to draw a straight line. That straight line is known as your horizontal line. So this AX will be your horizontal line. Okay? And horizontal line should always be parallel to the ground level, okay, to the surface of the ground. Now, what is this observer doing? This observer, he is looking down at the car, which is approaching, which is coming towards the foot of the tower. This observer, or let me bring an object, all right? Okay. Okay, class, we are right here. So I was saying that a straight highway is leading to the foot of the tower. Observer is at the top of the tower. So from the observer eye, we always need to draw a straight line known as the horizontal line. So this observer is noticing a car. And that car is coming towards the foot of the tower without changing the speed. See, this is your car. This is your car right here, okay? So the car is coming towards the foot of the tower without changing the speed, okay? Without changing the speed, it is coming towards the foot of the tower. As this car approaches the foot of the tower with a uniform speed, suppose, okay, the car is coming towards the foot of the tower with a uniform speed, all right? So when the observer first look down at the car, when the observer first looked down at the car is here. So when the observer first looked down at the car, the angle of depression was found to be equal to 30 degrees. Okay? The car is coming towards the foot of the tower, okay, without changing the speed. So when the observer first looked down at the car, the angle of depression was found to be 30 degrees. Angle of depression means angle between the horizontal line and the line of sight. Okay? So that's your angle of depression, and that is equal to 30 degrees. So at first, when the observer looked down, the car was at position C. In that case, the angle of depression was 30 degrees. But the car is not stopping, okay? The car is coming towards the foot of the tower, approaching the foot of the tower. Okay? So when the observer looked down at first, the car was at C. At that time, the angle of depression was 30 degrees. Now, the car is continuing to approach the foot of the tower, right? The car without stopping, continues to approach the foot of the tower. After 6 seconds, the car suppose reaches that point more closer to the tower. Okay? So time taken by the car in going from C to D, okay, is 6 seconds. Time taken is 6 seconds. Time taken by the car in going from C to D is 6 seconds. So when the car reaches this position after 6 seconds, when he looked down, the angle of depression, AX is your horizontal line. This time AD is the line of sight. So the angle of depression is now found to be 60 degrees. Okay? Now, question is, find the time taken by the car to reach the foot of the tower from that point. Car is coming. When the car reaches point C, the observer look down, angle of depression is 30. The car continues to go towards the foot of the tower. After 6 seconds, the car reaches the point D. And then when the observer look down, it's found to be 60 degrees. Now you need to find out, okay, you need to find out how much time did the car take in order to reach the foot of the tower from this point D. The car is coming. When the car reaches C, the observer looked down, angle of depression was 30 degrees. The car continues to move towards the foot of the tower. After 6 seconds, the car reaches D. At the time when the observer looked down, the angle of depression is found to be 60. The car still continues to go to the foot of the tower. So you have to find out the time taken by the car in going from D to, how much time did the car take in going from D to? It is what we require. Are you clear? Okay? Yes. All right. So now what we are going to do here is, so wet. So wet. Okay, let's see how it is done. You look very carefully. AX and BC are parallel lines. AX and BC are parallel lines. Okay, these are parallel lines. AC is your transversal. AC is your transversal. This angle is 30 degree. This angle is 30 degree. Then, due to alternate interior angles, this angle will also be 30 degree. So this angle is 30 degree. That is due to alternate interior angles. All right. The same thing again. The same thing again. What we have is, since AX and BC are parallel, so if this angle is 60 degree, then due to alternate interior angles, this angle will also be equal to 60 degree. All right. And we know that the tower always stands perpendicular to the ground. Okay. So we have two right triangles altogether. One is your ABD, and the other right triangle is ABC. Two right triangles, ABD, the first one, and the bigger right triangle, ABC. So time taken by the car in going from C to D is 6 seconds. And our objective is to find the time taken by the car in going from D to D. Now see, since the beginning of the journey till the end, the car was moving with a uniform speed. The speed of the car did not change. All right. So what I'm going to do is let the uniform speed of the car be x meters per second. Let me take speed in terms of meter per second. That means distance will be given in meters, time in seconds, so the speed will be meter per second, okay? Starting from the beginning till the end of the journey, the car moves with a uniform speed. That means the speed of the car didn't change. So let that speed be x, all right? So this kind of question is not that much practically applicable. Because if the car is moving at, say, 100 meter per second, that means till the car reaches the foot of the tower, its speed did not change, right? So the car will travel with this 100 meter per second, crosses the point C, crosses the point D, and it will hit the foot of the tower with this speed, killing all the passengers. Is that okay? That's what the question told. That's what the question is informing us, all right? So not that much practically applicable. Because if the car did not change its speed, then it will hit the foot of the tower with this speed. So there can be some casualties over there, okay? Yeah. Actually, when you are traveling, okay, your speed should not be uniform. It should be variable, right? Because as you come closer to the foot of the tower, you need to slow it down, right? Is it okay? So that you can stop right at it. But here the question says uniform speed. So the speed of the car did not change. That means if the car is going at a speed of 200 km per hour, and it will hit the foot of the tower with this speed, okay, killing everyone inside the car, okay. But let us forget about the casualties, okay. Let us try how to solve this problem only. So starting from the beginning till the end of the journey, the speed of the car did not change. So I have taken that speed to be x, okay. Now, what is the time taken by the car? Time taken by the car in going from C to D. From C to D. See? Time taken by the car in going from C to D. At C, the angle was 30 degree. At D, the angle changed to 60 degree. Okay, the angle changed. So, Question says that time taken by the car to change the angle of elevation from 30 degree to 60 degree is given to be 6 seconds. Is it clear? 6 seconds. Do they say 6 seconds? Yeah. Okay. Car is coming towards the foot of the tower. When the car is at this position, when the observer look down, it's 30 degree. Question says, 6 seconds later, the angle of depression changed to 60 degree. That means time taken by the car in going from this position to this position is 6 seconds. All right. So since we know the speed of the car and we know the time taken by the car in going from C to D, so let us find out what is this distance CD. Therefore, distance CD will be given by distance means speed into time. Speed into time. Speed is x meters per second. Time is 6 seconds. So the distance will be 6x meters. All right. Since we know the speed of the car, which is x meters per second, and we also know that the time taken by the car in going from C to D is 6 seconds. So the distance covered, okay, distance covered in 6 seconds. That means distance CD will be equal to speed into time. Speed is always the same, x, and time taken by the car in going from C to D is 6 seconds. So speed into time gives us the distance in meters, okay? Speed means meter per second, time in seconds, so distance will be in meters, all right? So the car take, that means distance traveled by the car in going from C to D is 6x meters. Now class C, you listen very carefully. We need to find the time taken by the car in going from D to B. We need to find the time taken by the car in going from D to B. So time taken by the car in going from D to B will be distance BD upon speed. Okay, distance divided by speed gives you the time. We already know that the speed did not change. So the speed of the car will still be x. So all we need to do is, in order to find out the time taken by the car in going from D to B, first of all, we need to calculate this distance dB. We need to calculate the distance dB. So that the time taken from D to B will be this distance dB divided by the speed. That will give you the required time. Is it clear with you? Are you clear with this question? Okay. So our main aim is to find out the distance dB. Once we get the distance dB, we can find out the time interval. Okay, we can find out the time interval of this path by using the formula distance upon speed. Distance upon speed gives you the time. Okay, that's how distance, speed, and time are related. Time means distance upon speed. Okay. So I'm going to start with a smaller right triangle. This is your smaller right triangle. In right triangle ABD, theta angle is 60 degree. So tan theta, tan 60, tan theta, theta is 60, tan theta means opposite side upon the adjacent side. Now tan 60 is square root of 3. AB is unknown. Distance BD is also unknown. So if you cross multiply, AB times 1, AB will be equal to square root of 3 times BD. AB is unknown, BD is unknown, so we can make that as equation number 1. Is it alright, class? Okay. Now let's consider the bigger right triangle. In right triangle ABC, this time your theta is 30 degree. So tan theta means opposite side upon the adjacent side. Opposite side is AB, adjacent side is BC. Tan 30 degree is 1 upon square root of 3. Your AB is unknown, but from equation 1, AB can be rewritten as square root of 3 times BD. From equation 1, AB can be written as square root of 3 times BD. Okay, from equation 1. And then BC. This BC can be expressed as BD plus CD. BD plus CD. BC means BD plus CD. Now 1 upon square root of 3 is equal to square root of 3 times BD upon BD plus CD. We have calculated distance CD. Distance CD we have calculated as 6x meters. Okay? Distance CD has been calculated as 6x meters. You cannot take CD. CD means length of a side. Length of a side cannot be taken in time. So that is why we calculated the length of CD, means distance CD, okay? Which was 6x meters. Now if you cross multiply, square root of 3 times square root of 3 is 3 times BD. And then BD plus 6x meters. BD we will assemble together on the left hand side. 3 times BD, this BD you can transpose it as minus BD is equal to 6x meters. Just normal calculations now. 3 BD minus BD. You have 3 BD. From 3 BD, if you subtract 1 BD, you have 2 more BD. So this implies twice BD is equal to 6x meters. So your BD will be 6x upon 2 meters. 3 times is 6. So your BD will be 3x meters. So this distance BD is 3x meters. Now you want to find out the time in going from D to B. So time taken by the car. Time taken by the car in going from D to B will be distance. Time taken from D to B means distance dB or BD, same thing. Distance dB upon speed of the car. Speed of the car remains the same throughout the journey. Now your distance dB has been calculated to be 3x meters. And the speed of the car is x meters per second. We can cancel x, we can cancel meter. So 3 seconds. So the car took 3 more seconds from this point D to reach the foot of the tower. Are we clear? That is our objective, and hence we have determined the objective of the primary objective of the question. Okay. So if this is clear to you, you can take your time noting it down, and then we shall start up with the last question of this chapter. Today we have 127 students. I think that's the maximum number. Okay. So class, if you are done, you can please comment on the chat that you are done so that we can proceed with the last question. Okay, all right. So if you're done, so we'll proceed with the last question of this chapter. Okay, one of the most interesting question. Now this is also a different type of question, okay, from this chapter. So a very important question for the examination point of view. This is the only question of its kind. You cannot find any other question in this exercise, okay, which resembles this question. So the last question of this chapter, question number 16, let us see, okay. After completing this question, I will give you a classwork to work out, and then we will see like who is the champion of today's class, all right? Yes. So question number 16, as I read the question, I want you to just focus on the question, okay? This question is also completely different from the previous questions, one of its kind. So let's see. The angles of elevation, elevation means you're looking up, okay? Angles of elevation, angles means there are two. Angles of elevation of the top of a tower from 2 points. It means you are looking up at the top of the tower from 2 different points. Let's say P and Q. Okay. You are looking up at the top of the tower. From where? From the ground, from 2 points on the ground, P and Q. At a distance of 4 meters and 9 meters from the foot of the tower. From the base of the tower means from the foot of the tower. That means you are looking up at the top of the tower from 2 points on the ground. One of the point is 4 meters away from the foot of the tower. The other point is 9 meters away from the foot of the tower. All the measurements are taken from the foot of the tower. Okay. One of the point is 4 meters away from the foot of the tower. Other point is 9 meters away from the foot of the tower. Okay. And also they say that the angles of elevation are complementary, or angles of elevation are not given. See, there is some difficulty with this question here. You are looking up at the top of the tower from 2 different points, right? The first point is at a distance of 4 meters from the foot of the tower. Second point is at a distance of 9 meters from the foot of the tower. But it's not given what are the angles of elevation. It's not given. But their relationship is given. They say that angles of elevation are complementary. Plus, 2 angles are said to be complementary if, what is the relation? If 2 angles are said to be complementary on what condition? 2 angles are said to be complementary if, I think there is one condition involved there. If what? Any comments? You've studied in class 7, 8, okay. You can comment, class. 2 angles are complementary if what? Okay, some of you have commented. 2 angles combined gives the 2 angle combined gives 90 degree. Combined means like how? Like fusion, or like how are they combined? Through by means of some materials Combines. Combined can mean different things, okay? Fusion is also combined. Added, yeah, added. Added means sum. Two angles are said to be complementary if their sum is equal to 90 degrees. Two angles are supplementary if their sum is 180 degrees, okay? Here, the problem with this question is angles of elevation are not given, but their relationship is given. What kind of relationship? They are complementary. Complementary means sum of the angles is equal to 90 degrees. Okay, so I'm going to use that information. Also, you want to prove something here? Look at the question. Prove that the height of the tower is 6 meters. Oh, they are asking us, okay, show that the height of the tower is 6 meters. All right. So there is a tower. There is the tower. AB is your tower. A is the top. B is the foot. Okay. Now you are looking up at the top of the tower from two different points. P is one point. Q is another point. So there are two different points. The first point is at a distance of 4 meters from the foot of the tower. Whereas the second point, this second point Q is at a distance of 9 meters from the foot of the tower. All the distances has been measured from the foot only, okay, from the foot of the tower. First point is at 4 meters from the foot of the tower. Second point is at a distance of 9 meters from the foot of the tower. Now from point P, you are looking up at the top of the tower because angle of elevation. From point Q, again, you are looking up at the top of the tower because it's angle of elevation. Okay? So these are the two angles of elevation, but it is not given to you. So this can be 60 degree, 30 degree, okay? We do not know. This can be 70, this can be 20, this can be 80, this can be 10, this can be 50, this can be 40. We cannot say, okay? Angles of elevation are not given, but it is given that these two angles are complementary, means the sum of these angles will be equal to 90 degrees. So, practically, I do not know what are the angles of elevation, right? So, if I take one of the angle of elevation to be theta, one of the angle to be theta, then what would be the other angle? Their sum should be 90 degrees. So if I take one of the angle to be theta, then what would be the other angle? Any comments? What? Someone is saying something? Go ahead. Ah, Talisinla commended, Akulundang commended. Okay, yes, thank you. Talisinla and Akulundang. So this angle and these angles are complementary, means their sum is 90 degrees. So if you have taken one of the angle to be theta, then the remaining angle will be 90 degree minus, only then their sum will be equal to 90 degrees. Okay? So this theta was not given, but you have considered it by your own. So we need to write that information. Okay? Anything that you write extra apart from what is given, you need to note it down always. Alright? It's very important. So I'm going to write like this. Let theta and 90 degree minus theta be the angles of elevation. Angles of elevation. From where? Theta is at P, right? From points, from 2 points where theta is at P. So from points P and this angle is from Q. So from P and Q to the top of the tower. You are looking up at the top of the tower. So to the top of the tower. So this information is very important for you to write. Is it all right? Yes, very important information for you to write. Okay. All right. Okay. So theta is the angle of elevation from this point P to the top of the tower. 90° minus theta is the angle of elevation from this point to the top of the tower. Okay. Now, we are going to prove that the height of the tower, AB is the tower, so we are going to prove that the height of the tower is 6 meters. Is it okay? Yeah. So to prove that height of the tower is equal to 6 meters. Now we have two right triangles because tower always stands perpendicular to the ground. Okay. So we have two right triangles. One is ABP, ABP, and the other one is ABQ. So we can always start with a smaller right triangle. So in right triangle ABP, angle is theta. So tan theta, for this triangle angle is theta. So tan theta means opposite side upon the adjacent side. Your adjacent side is BP. So tan theta is equal to AB is unknown, not given. BP is 4 meters. Plus C. Don't cross multiply over here because you do not know what is theta. You do not know what is AB. Okay, so there is nothing to be done here. You can just make it as equation number 1. Now let us go for the bigger right triangle. In right triangle ABQ, the bigger one. Okay. Tan theta, instead of theta, for the bigger right triangle, instead of theta, your angle is 90° minus theta. In place of theta angle, you have 90° minus theta. So tan theta, just think that this is theta. Tan of some angle means opposite side upon the adjacent side. This time your adjacent side is BQ, the longer side BQ. Now class, very important information here. What is sine 90° minus theta? Complementary angle formulas. Sine 90° minus theta, cos theta. Cos 90° minus theta, sine theta. Then what is tan 90° minus theta? Tan 90° minus theta. Complementary angle formulas, exercise 8.3, chapter 8, trigonometry, class 10 maths. What is tan 90° minus theta? I have one comment here. Cot. Yes, Autula has commented cot. Yes, Tadisana commented cot theta. Okay, very good. So tan 90° minus theta will be cot theta. AB is unknown, but your BQ is known. It's 9 meters. The same thing over here. AB is unknown, theta is unknown, nothing can be done. So mark it as equation. Now what I'm going to do is, I'm going to combine this equation 1 and 2. That means I'm going to multiply equations 1 and 2. Just multiply equations 1 and 2. Whenever you multiply two equations, left-hand side will be multiplied with left-hand side. Right-hand side will be multiplied with right-hand side. Okay? Whenever you multiply two equations, left-hand side gets multiplied with left-hand side. So tan theta gets multiplied with cot theta is equal to right-hand side gets multiplied with right-hand side. AB upon 4 meters times AB upon 9 meters. Plus reciprocal formula you have studied in trigonometry since exercise 8.1, 8.1, 8.2, 8.3, 8.4. Every exercise of chapter 8 you have applied this reciprocal formula. What is the reciprocal formula? Like sine theta is 1 upon cosec theta. Cosec theta is 1 upon sine theta. These are known as your reciprocal formula. Cos theta means 1 upon sec theta. Sec theta means 1 upon cos theta. Tan theta will be 1 upon cot theta. Cot theta means 1 upon tan theta. These are known as your reciprocal formulas. Okay. Yes. So in that case, tan theta times cot theta means 1 upon tan theta. Cot theta means 1 upon tan theta. This is known as the reciprocal formula. Tan 90 degree minus theta is also equal to cot theta. This is known as your complementary angle formulas. So if you do not know these formulas, okay, better you don't study any trigonometry. AB into AB, AB holding square. 49 times is 36 meter into meter, square meter. Tan theta cancels out. So we have 1 is equal to AB holding square upon 36 square meter. Let us cross multiply. If you cross multiply, AB holding square would be equal to 36 square meters. So AB would be square. If you transpose it to the other side, it becomes square root. Square root of 36 is 6. So we have proved that the height of the tower is 6 meters, which completes our answer. Okay, so our objective was to prove that the height of the tower is 6 meters, which we have done it, so that completes our proof. And then that completes our chapter 9. All right? Yes. So you can please note it down. And then once you are done, we can work out with some exercise problems. Plus, if you're done, okay, everyone says you're done, all right? So if you're done, so just let me give you one question as a classwork. Okay, just only one question as a classwork, and you'll be getting some questions for the assignment. Okay, maybe tonight or tomorrow. And very easy question, okay? Similarly to what we have done just now, just similar to that, with some changes here and there, okay? Okay. The question says, the angles of elevation, the angles of elevation of the top of a tower. Angles of elevation of the top of a tower from 2 points on the ground. From 2 points on the ground. On the ground. From 2 points on the ground at distances A and B. At distances A and B. At distances A and B. Units. It means it can be A centimeter, B centimeter, A meter, B meter, A kilometer, B kilometer. It can be anything, okay? A and B units from the base of the tower. From the base of the tower. And in the same straight line we did. And in the same straight line straight line with it are complementary. So prove that the height of the tower is, prove that the height of the tower is square root of a. 5 minutes for solving this question. I have some comments here. Sir, excuse me, Satyam, you have any problem regarding the questions or anything? You can see. If you cannot see, then what can I do? You need to consult with your server, okay? The network that you are following. Thus, just in the previous question, wherever their theta and 90 minus theta would be same, instead of 4 meters, it's A. Instead of 9 meters, this time it's B. So answer, instead of 6 meters, you will get square root of AB. That's the only difference, nothing much apart from that. Anyone who has done can please comment on the chat. Your 5 minutes is past. If someone commented, okay, done. All right, so one student could complete within this time interval, Zila. So the champion for today's class, okay, would be Zila. Okay, three of you are done already, but The first one only would be considered as the winner, no? So the winner for today's class will be Zila Aono, okay? So next week we will start up with another chapter, okay? Most probably chapter 6. But before that, maybe tomorrow or day after tomorrow, I'll be uploading some assignments basing on what we have done, right? So stay tuned and study hard. You can log out now. Thank you for your attendance. Thank you for learning.